Clayton Locke, creator of the YouTube channel Physics Boy, and welcome to Lesson 1 of Clayton's outro class, also known as AP Physics Final Exam Review, also known as Physics by Clayton. Today's lesson, nuclear physics. What is nuclear physics, you ask? Well, nuclear physics basically is the study of nuclei and the interactions between other nuclei. One of the first nuclear physicists was Henry Becquerel. While studying phosphorescence in uranium salts, he discovered that the plate he placed the uranium on became foggy and acted peculiar under electric and magnetic fields. His discovery helped Pierre and Marie Curie to discover new radioactive atoms. Discovery of radioactivity. Before we go into the main elements of nuclear physics, I should explain radiation. Radiation is when very small, unstable particles in objects emit energy, or smaller and possibly unstable particles. Radiation is used daily in radiation therapy by using beams of X-ray, protons, and many other types of energy to kill off cancer cells. Kind of fascinating. Now there are four main parts of nuclear physics: fission, fusion, nuclear decay, and transmutation. Fission is quite important in our daily lives. Its most notable use is in nuclear power plants. But before I go into detail about power plants, I need to show you how fission works. Okay, fission begins with a large, unstable isotope, like this. I'll name him Bob. Let's say he is uranium-235, which is used in a majority of nuclear power reactors to this day. Now this isotope has a little friend named Jimmy. Jimmy is a neutron, and this neutron is flying incredibly fast and slams into Bob. Smaller isotopes break off, little isotopes, from the larger isotopes, and various high-speed neutrons also break off. The reason that this is a popular method of gaining power is that there is a large amount of energy that is produced from the isotope breaking away. Enrico Fermi, an Italian physicist, created the first man-made nuclear chain reaction using this principle. Fun fact, this reactor was built underneath the University of Chicago's football stadium. Nuclear fission reactors are currently being used to this day. They utilize the same principle in breaking down molecules to create energy. Fission reactors put out a lot of power, but there's an idea that may possibly be the safer, cleaner, and more productive successor to this great invention. Fusion, on the other hand, and in short terms, is a merging of separate elements into a unified whole. It starts with two unstable isotopes. In this case, I will use the hydrogen isotopes of deuterium and tritium. These isotopes fuse together. The results become helium. Helium, various neutrons, and an immense amount of energy, several times larger than fission. In the 1930s, Hans Bethe was one of the scientists who discovered that fusion was possible, and it was an energy source of the sun. This newer form of energy would be much cleaner. If it was possible to overcome the amounts of heat, then millions can be given this source of power that is very safe and clean. Nuclear decay is another form of nuclear physics. The most memorable term for this is half-life. Simply put, half-life is the time it takes for half of a substance to decay. This is used in carbon dating. Carbon-14 is used to determine the approximate age of organic objects. This, along with transmutation, finishes off the parts of nuclear physics. Transmutation is where radiation is used to change one element into another. This concept, which is now more of a practical use, was founded by a physicist named Frederick Soddy. He partnered with Ernest Rutherford when they discovered that thorium was naturally turning itself into radium. The LHC, or Large Hadron Collider, utilizes transmutation. It is the largest and most powerful particle accelerator in the world. Based in Geneva, Switzerland, this Large Hadron Collider is a 27-kilometer ring that moves particles at about the speed of light and collides them with different materials. This can induce transmutation and changes the makeup of molecules. The LHC is used for mostly researching particle physics and not for giving superpowers. Particle accelerators, like the LHC, prove that we can create new elements beyond what we see naturally form. The production of synthetic elements past americium doesn't have stable isotopes that can cause it to be found naturally. The elements go up to 118, which we believe may be the maximum height of the elements, but it is a possibility that we may hopefully see a new row form in the future. A very interesting and quite confusing concept is antimatter. Basically, antimatter acts as the opposite of the particles that we find normal. They act opposite and contain opposite charges to these particles. Let's end this off with a banger. Atomic weaponry. This revolutionary use of nuclear fission changed the world and opened up new opportunities in a way of atomic energy. Thanks for watching, and if you like what you saw, click here for a link to Physics Girl's channel to view what she has. Bye.